And welcome to topic 2. If anyone has a better opening for me, I'd love to hear your ideas. Topic 2 will be on molar mass. So this is the second portion of the test. This is going to be converting from mass to moles or moles to mass in the same chemical. So if I were changing chemicals, that would be a more than one step problem, and that would include using the mole ratio. For our limiting reaction problems that we're working on this week in addition, this is going to include the first and last steps of those problems, assuming that they start with giving you mass and they ask you for mass in the end. Okay, we're going to start just like we have with the other videos, and we're just going to walk through the problems. So 12 moles of potassium is what you're given, and you're asked to find how many grams of potassium would be the mass for 12 moles of potassium. So I'm going to demonstrate our same multiply by a line technique, and you're going to see this goes on top, grams of potassium. The unit we know already goes on bottom, moles of potassium. The purpose here is these two cancel out and I'm left with the unit that I want. Anytime I see grams per mole, I should be thinking molar mass, and I should be looking at my periodic table. Okay, so grams per mole of potassium, 1 goes here because in terms of molar mass, this is the mass of 1 mole. And then my molar mass on the periodic table goes here. And as I quickly look it up, yay, potassium is 39.1. Okay, so we're going to take 39.1. We're going to take 12 times 39.1, and that will give us our final answer. You should go ahead and plug this in. I will put in these answers at the end of the video. Okay, 24 moles to grams of nitrogen. Oh, we're just going to call this the nitrogen compound because I actually don't know the name of this one at the moment. I will look it up and put it at the end of the video. Okay, so units we know go on bottom. This number stays here. We don't put this number down here. Some of you have been hearing put the thing we know on the bottom and have been moving the number as well. Don't move the number. Leave the number there and just move the unit. Okay, then the unit we want goes on top. Okay? Now, again, I see grams per mole, so I should be thinking molar mass and I should be looking at the periodic table. In order to add up the molar mass of this compound, I need to take the molar mass of nitrogen. MM stands for molar mass. I need to add it to the molar mass of hydrogen, which I'm going to multiply by 2 because there are 2 hydrogen atoms here. And then I'm going to add it to the molar mass of oxygen. Okay, so that is going to be, nitrogen is 14, oxygen is 16, and hydrogen is 1. So we're going to take 14 plus 2.02 plus 16, okay? And that will give us the molar mass that we're going to put up here. This we will fill in with a 1, just like we did before, because for a molar mass, that's the mass of 1 mole. So we have 14 plus 2 gives us 16.02 plus 16 gives us 32.02. Okay, you go ahead and put that in your calculator and check the answer at the end of the video. Okay, now here we are going from moles to grams. When you're using this with your limiting reactant problems, this will probably actually be the very last step. When you've got the number of moles of whatever compound you're looking at, and you are solving for the grams so you know what mass will be produced. However, when you start, you're often going to be given grams, and this should have the compound here, as should this. And then you need to transfer to moles. So why do we transfer to moles? We transfer to moles because our chemical reactions tell us the relationship in terms of numbers of particles and not in terms of the mass of those particles. So if we take 200 grams, we're going to put our grams on the bottom and our moles on the top. This looks different than this, right? But what it really is the same thing, except upside down. So if I were going to set this up, I would put in 1 here, and I would put in the molar mass of beryllium, which is 9.01 here. Okay. Now, when we multiply by 1 over a number, that is the same as taking 200 and dividing it by 9.01. So when you plug this into your calculator, you can just take 200 and divide it by 9.01. I've seen a lot of you take this number and put in the coefficients. This number should always be 1 because it's the molar mass. Okay, you are going to solve this problem. The answer will be at the end of the video. Okay, one last demonstration. Here, same situation. Our grams are going to be on the bottom and our moles are going to be on the top. So when you actually plug this into your calculator, you can just take the grams that you have and divide it by the molar mass to get the moles of calcium nitrate. To get the molar mass of calcium nitrate, we need to take the molar mass of calcium, add it to the molar mass of nitrogen, and then add it to the molar mass of oxygen times 3. Now, the other question I get a lot is that do I need to multiply my molar mass by the coefficient? You do not multiply your molar mass by the coefficient. The point of the molar mass is that it's 1 mole. So you're just adding the numbers up and doing any multiplication using subscripts because you need more mass for each of those individual oxygen atoms that are in that molecule. So if we take a moment to find these numbers, we will get 40 plus 14 plus 16 times 3. 6 times 3 is 18. And then 1 plus, so that's 48. Okay, so let's watch Mrs. Golden do some math in her head. So I'm going to write this vertically so I can see it. Okay, 4 plus 8 is 12. 8, 9, 10, 102. Okay, so here we are taking grams and turning them into moles. We do division by the molar mass. Molar mass is purely the masses off of the periodic table, and you multiply by any subscripts. You don't consider any coefficients when you're doing these equations. Okay, and then in just a moment you will see the answers because editing is magic. Answer to number 4 should be 469.2. Answer to number 4B should be 768. Answer to 5 should be 22.2 or 22.1975, blah, 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 blah. And 5B should be 0.232. Give yourself a high five, or high five the person next to you if you got all 4 answers right. Good work.